In this video, I'm going to show how we may derive the best parameters for a linear regression model. Let us recall a little bit that in the linear regression model, we would like to minimize the sum squared of the residual or the error. And then we measure the error basically is the difference between the actual value of the instance that we observe with the prediction that is made by the linear regression, which falls in this line. Okay, so here we have the error squared, and then so this is the error, and then we take the squared of the error and take the sum of all the errors, and then it may be broken down into this part is the actual y value, the actual observed value of an instance, and this is the prediction from our linear regression. So we can say it's the difference between y and y hat, and then y hat itself in the regression model is beta 1x plus beta 0, and then we rearrange the terms so we arrive at this function. We would like to minimize this function. Okay. We have seen from the previous videos that these are the results. So this is the beta 1 and this is the beta 0. Now in the next slides, I'm going to show you how we may derive these formulas. So we start with the function that we would like to minimize, which is the error function or the loss function. And then with respect to each parameter, we are going to take the first derivative of the function and then set it to 0. Okay, so for example, here we take the derivative with respect to beta 0. So take the derivative of this function, the power goes down to the front, so it goes there, and then we have this function here, so we still have that function, and then we derive that function with respect to beta 0. So we have this minus here, this minus go there in the front. Okay, so that's the derivative with the with respect to beta 0, and we're going to set it equals 0. For beta 1, it's similar. So first the power, the power 2 goes down to the front, and then the function here remains the same. But now when we derive this function with respect to beta 1 only, we will have xi. So that's why we have xi there, and then we still have this minus that goes to the front. We again will set this derivative equals 0. Now let us solve this derivative of L with respect to beta 0, and then we set it to 0. So first we realize that minus 2 times something equals 0. So this something must be 0. So we ignore the minus 2. Okay. And then next we take the summation into inside the parenthesis, and then it will become the sum for each term. Okay. And then we realize that we may move this thing into the other side, so, because finally we would like to have beta 0 equals something, right? So just we move it to the other side, and then here we see that this thing here, sigma beta 0 from I equals to n equals to beta 0 times beta 0 times beta 0 times times beta 0 n times. So we say this thing here equals n times beta 0. And then at the same time, we may move this beta 1 go to the front of the sigma because it does not have the subscript I. Okay, so because this sigma is for I equals 1 to n, this beta 1 does not have anything to do with I, so it can go out from the sigma. And then finally, we divide everything with n. So beta 0 equals sigma yi over n minus beta 1 times sigma xi over n. And then it may be simplified further by saying that when you take the sum of yi and then divide it by n, you denote it by y bar, and then here you denote it with x bar. So here we have reached the same result with the one that is given in the theorem. Now let's do the derivation for beta 1. Same as before, we first ignore this minus 2, and then we bring the sigma inside. So now each term has the sigma term. Okay, and same as before, because sigma times beta 0 times xi, this beta 0 does not have any subscript I, so it may go to the front of the sigma. Okay, so that is the first step. And then next we realize that beta 0 is this, which y bar is sigma yi over n, and then x bar is sigma xi over n. So we replace this beta 0 with this thing. Okay, and then the next step, we multiply this sigma xi to the things inside the square brackets. Okay, now be careful between sigma xi squared and so sigma xi and then squared with sigma xi squared. Okay, so there are two different things, so please pay attention to them. Okay, and then up to this point, the next thing we are going to do is that we are going to move the terms with beta 1 to the other side. Okay, we move them to the other side, and then I guess we do nothing else here. And then here we just group these things. So take the beta 1 to the front and then group these things. And then we simply finally can say that beta 1 equals to that divided by this thing in the bracket. So it's the same with the previous one that we saw in the theorem. So that's how we derive the beta 1. So the beta 1 and beta 0 that we just derived will describe the gradient and the constant of the regression line. And this line is guaranteed to minimize the total sum of squared between the actual observed value and the predicted value from the regression line. In this case, in this example, the line will say the share price equals beta 1 times revenue plus beta 0. So this concludes all the videos about linear regression. Thank you.